Hi, my name is Tony Gibbs. I'm a Principal Database Solution Architect for Amazon Timestream here at AWS. In this session, we're going to walk through getting started with Amazon Timestream. We're going to start out first just by introducing what Timestream is. We're going to go into some architectural concepts, some of the terminology and such that we use in Timestream that's unique to it. Then we're going to cover how data ingestion is done, move on into query processing. We're going to talk about some of the integrations that we support for the launch of Amazon Timestream. And then after that, we're going to go through just a quick tour of the console. And in that console, we're going to create a sample database, walk through how you query data, and all that kind of thing. So let's first start out by talking a little bit about what time series data is. Now, time series data, it really is about measuring some sort of value, whether that value is maybe the speed of a car, the price of a stock, maybe the oil pressure, and some sort of machinery. And it's really about measuring that over some time period. And we might be sampling those measurements on a regular basis, whether it was every second or every minute or whatever it happened to be. Now, that means that everything that goes into a time series database like Amazon Timestream is going to have an associated timestamp with it. And it really is about measuring these data points as they vary over time. So you pretty much almost always see like an x-axis like this one along the bottom with a timestamp that's changing over time. So the typical use cases for a time series database, the first one is really IoT data. A lot of IoT use cases use time series databases, and that's, you might have sensors, again, that are collecting whether it's weather information like the temperature, the humidity, those sorts of things. Or it could even be like, sensors on a truck that are, measuring things like the speed and location and such. Then we have DevOps data, and these might be, maybe you have a fleet of instances that are running on AWS, for example, or maybe containers, Kubernetes or something like that, and you're measuring the memory utilization, how much network data is being transferred, your CPU usage, all of those things. And that could be used maybe just for powering dashboards and such on the load that are on the servers and keeping an eye on things and alerts and things like that. Then the last one is app analytics, and this one's kind of a much larger one because it encompasses a lot of different use cases. But some of the common ones we've seen so far from customers are things like clickstream data, maybe measuring, like, for example, like the time it takes for a page to load, how much time a user spent on a page, or it even could be all the way over into like video analytics where you're measuring when a user pauses a video or when the resolution changes because of bit rate can't keep up or something like that. So those could all be use cases that might fall under that app analytics. Now, traditionally in the past, we probably would have put this data in a relational database. But relational databases, they're typically vertically scaled. Most of them aren't able to scale horizontally. So a lot of relational databases aren't going to be able to handle this, and if you do need to scale horizontally, you're going to end up doing things like, sharding your data and things like that, and that causes other types of issues. Then relational databases are also typically, they have schemas and things like that you need to define. There's a DDL that needs to be issued if you're changing a data type or if you're adding a new column, and just because you've deployed a new IoT sensor, for example. Then there's also a lot of visualization tools, machine learning tools and such that are built around getting the data into, for example, these newer types of time series databases. And a lot of these don't necessarily support relational databases as well. Then we do have some existing time series solutions, and what we've heard from customers is a lot of these solutions are difficult to scale, or a lot of work to maintain, or they get expensive because there's no life cycle management where you're all your data resides in the database, and then you start having to offload that data, and then you end up having, for example, to need to have a different database to query that historical data, maybe for generating reports and that sort of thing. So these are some of the challenges that we've heard that customers face when they're either using relational databases or some of the existing time series solutions. So let's go into what Timestream actually is. So it is a serverless database. It's designed to be easy to use. There's no configurations or picking instance types of any sort. So you're not, configuring a cluster. You're not having to worry about software patches. All of these sorts of things completely handled for you. Then this means that you pay only for what you're going to actually ingest, store, and query. And all three of these things are separate in Timestream. We also have the ability to automatically have lifecycle policies that move data from one storage tier to another that can also help reduce costs as well. We also built Timestream to be entirely scalable. So there's no, like I mentioned earlier, there's no configuration that needs to be done as far as database indexes or anything like that. And then behind the scenes, the service scales automatically as you begin to ingest more data or as you begin to query the system with more users, for example, or more dashboards and that sort of thing. We wanted it to also, this kind of falls under our ease of use, but really the point of it being a time series database is that we do support standard SQL. We wanted to support, we didn't want to support a proprietary query language. We wanted it to be something that customers expected and were able to pick up and just easily work with. We did add in interpolation functions and time series functions and that sort of thing, so that those are gap filling and all of that are expected in a time series database as well and required. Obviously, being AWS, security is number one, so everything in Timestream is encrypted, both at rest and in flight. The first thing you do when you create a database after giving it a name is assign a KMS key to it, and then all data is encrypted, and it's not just by default, that's just the only choice there is. So because Timestream is serverless, that means that we do continuous releases to it. There's no maintenance, there's no downtime, there's really just keep an eye on the AWS forums for the latest release information, and we just continuously are rolling out updates and patches and fixes. There's no operating systems, no nothing to worry about, and that means that Timestream is just continuously getting better. It's just continually improving, and those features will just continue to roll out over time. So let's talk a little bit about the tables in Timestream. So as I mentioned earlier, all tables are encrypted. Every table holds some number of records, and there isn't a data definition. Like when you create a table in Timestream, you're not specifying DDL and specifying columns up front. Instead, the columns are added to Timestream as the data is ingested, and Timestream will figure out what needs to be added and what doesn't. The only configuration that you actually do when you create a table is add the how long you want to retain the data in the various storage tiers. So we have two storage tiers in Timestream. We have an in-memory tier and a magnetic tier, and they're designed for slightly different things. The in-memory tier handles the ingestion of all data. It also handles deduplication of data. So if there were, for example, the same data point was sent to Timestream twice, Timestream would actually drop the second data point and it wouldn't recognize that was a duplicate. The in-memory tier and the magnetic tier are actually designed for slightly different use cases. We were talking earlier about the needing to separate workloads maybe for analytics versus the dashboards, for example, and sometimes having to use another system. In Timestream, you don't need to do that. Our magnetic tier is actually designed for high performance analytics queries for maybe running reports and that sort of thing, Whereas our in-memory tier, it's designed for that high throughput of ingestion, and it's also designed for narrow queries that are hitting and needing to extract slivers of data very quickly, or maybe even pulling data out and aggregating it and such. So maybe typical queries in there might be over the last 1 or 2 hours or something like that, where you're pulling out all these data points. Whereas, like I said, the magnetic tier, you might have queries that are running month-over-month reports, for example. So the next piece of terminology or concept to introduce you to are dimensions. Every record in Timestream has at least a single dimension. A table supports up to 128 of these unique dimensions. And every dimension in Timestream is represented as a varchar. And they, like I mentioned earlier, they're added dynamically at ingestion time. So just to kind of go over this particular example, we have some records, in this case some records for Timestream in a table here. And what you'll see here, looking over the top there, is these would be the user-defined dimensions. So region, availability zone, VPC, and host name in this particular case make up what would be that unique set of dimensions. So then we have measures. So every record in Timestream contains a single record. So every single record, there is one measurement for it. Each table supports up to 1,024 unique measurements, and as I mentioned earlier, these are also dynamically added in ingestion. They support all the typical data types that you're usually going to be measuring. The most two common ones are obviously usually big ints and doubles. Are the commonly measured data types. So looking at the same table here, you notice up at the top here, I have the measure name, which is what uniquely, tells us what we're going to be measuring. And then we have the measurement value there. And what you'll notice is that : double, and in the other case, : big int. And that's the data type that you've specified when you're writing that data in. And so if, for example, you had never sent any data with a big int, for example, you actually wouldn't see that column for those records at all, or even in the table. So these are all dynamically added at runtime as well. And then obviously you can have different types of records that have these different measures, which you'd see things like this. So then the next is what time series are, and what time series obviously is it's that unique set of records over the data points, and we were kind of talking about that, and this is what a series is. Of data points. We were talking earlier what we're actually measuring and what that measurement is and how it's varying over time. So I think this next point here, or the first point underneath the blue line there, is that obviously every record is going to have one of these timestamps, at least one dimension, and then it's the associated measure value pair. And then those records that have that unique set of dimensions and measure name, those records vary over time for that measurement, that's what makes up the series or the time series. Then we also do, not to be entirely confused by it, but we do also have what we call a time series object, which is constructed in Timestream. So you can feed a series of data points into the time series function and it'll generate this, and then that's where you can apply things like the gap filling functions and stuff like that, like our last observation carry forward, for example. And if there was a gap, for example, that would carry over the previous data point into that gap and fill it in. So that's it. You use like a function like that to fill in missing data points. So just getting into these series of data points here. So in this particular example here, you can see that the CPU utilization for this unique set of dimensions is varying over the timestamp there on the left, and then the measurement value, which would be the CPU utilization as it changes over time. And that's really what the series of data points would be. Some of this is a bit of a summary, so I'm not going to repeat the exact same things over, but a few characteristics of data in Timestream that are worth calling out are that you can't delete data and you can't update data in Timestream. So all data that's sent to Timestream, it is an append-only table, and the data isn't removed until it actually hits the end of its retention window in that tier. So obviously in the in-memory tier, it would then move to the magnetic tier, and then when it hits the end of the window on the magnetic tier, that's when it would be removed from the system. Now, I mentioned the first writer win semantics on the duplicate data, so that's the semantics that we use is a first writer wins if multiple data sets of data points are sent that are exactly the same set of dimensions and timestamp, and then that'll determine that. The last thing worth calling out is that Timestream is designed for handling high-speed real-time data. So what that means is that you could have, maybe you have your whole fleet of EC2 instances or containers or whatever it is that you're doing DevOps data on. Each of them can all be sending data directly into Timestream, all in real time, and Timestream is capable of handling that. In certain cases, it may still make sense to use something like Kinesis, for example, to capture that data, especially if you were wanting to do different types of analysis and maybe feed that data into a different system as well, like Elasticsearch, for example, and do other work that maybe Timestream isn't designed for. So let's get into how you move data into Timestream. So writing data into Timestream is done through the AWS SDKs. So we support, obviously the common development languages like Java and Python and Go and Node.js and such. And then obviously through the AWS CLI is obviously another option as well. Then we have some adapters and plugins. AWS IoT Core does have native integration through the rules engine with Timestream. And then we have a couple of connectors that we have up on GitHub that we've published. One's for Apache Flink that works with Kinesis Data Analytics. And another one is Telegraph Connector, as we've had a good number of customers ask for Telegraph support to send data directly into Timestream. Just to give an example, this code is written in Python. This is a small snippet of code that's sending CPU and memory utilization into Timestream. I won't get into all the details of what common table attributes are, but that would be for a deeper session and where we're talking about optimizing and how you'd maybe thread data, do multi-threaded writing and all that sort of thing. But this is just a simple example of how you would send data into Timestream, and it is fairly simple. So in the query side of things, we mostly support ANSI SQL 2003 for the querying. The one piece that's not there is table joins. So we do support table joins, but only to this same table. So you can't join across from one table to another table. So yeah, we do only support, you could do just to give an example, you could do a self-table join to the same table using like a common table expression, which is technically behind the scenes generating some, maybe temp data and that sort of thing. You can join between, things within a single query to yourself, whether it's, through a common table expression or some other semantic, just a self-join. This does mean that because we do support standard SQL, that you don't need to, learn any new language. It is just standard SQL, and we do support all of the common functions I think that most customers would expect, such as scalars and aggregates and windowing functions and stuff, and obviously the time series and interpolation functions, which I talked about a few slides ago, that we also have added. Data is queried. It can be queried through the exact same set of SDKs for Java and Python and such, or it can also be queried through JDBC. We do have a JDBC driver that you could, if you're writing code in Java, you could use that instead of the Java SDK, and that might give you more of a common interface. It's going to feel more like a database. Again, here's just a quick example of some of the of SQL written against Timestream, and you can see the various breadth of functions like approximate percentiles and averages and round functions and bin functions and all that kind of stuff. And again, like I said, we cover and have support for most of the common things that you'd be used to if you're used to a standard relational database that has standard relational SQL database, I should say. So let's go through some of the integrations that we support. So we do have the Amazon QuickSight team has built support for Timestream. So if you're a QuickSight user, you'll be able to go and begin running reports and such against Timestream. We also have, the AWS IoT Core, which I mentioned earlier, can send data into Amazon Timestream. Grafana, that is also one that is commonly asked for. So we do have, or Grafana supports a plugin with the open source edition that works with Timestream as well. Through our JDBC driver, you'll find that most of the common SQL development tools and such work with Timestream. And then, as I mentioned earlier, the various connectors and stuff that talked about, we have those are all up on GitHub, and yeah, that's where you'd go to find those. So just to give a quick example of Timestream plus JDBC, this is just off my development environment. This screenshot here, and you can see, this is me just working on my just a SQL query. I was writing some sample queries and such, and it's pretty simple and straightforward to hook up these tools to work with Timestream. This is screenshot of Timestream and Grafana working. This was also some sample data that was sent in over several hours, and you can see kind of the, in this case, there's actually one of the create time series functions there, running this data against Timestream from Grafana. This is also Timestream plus Grafana. This one's not quite the line charts, but some of the other types of things, visualizations that Grafana supports. And then we have Timestream running against QuickSight as well. So what we're going to do is, at this point, we're going to cut over to the console tour. All right, now that we're in the Amazon Timestream console, you're going to notice that there's this link over here which takes you over to the pricing. Expanding this panel here on the left, you're going to notice things like the database, query editor, and monitoring and such. I'm just going to go ahead and click this Create Database button over here. What you're going to notice is you have the sample database, standard database as your kind of two options when you come in here. I'm just going to click on the standard database for a second here, and you're going to notice you can give this database a name, pick a KMS key, and optionally add tags to this database. You go back to the sample database here, and you, as I mentioned before, you add a name to this. I'm just going to just add some name, and then down below here we have two options for tables. So we can create an IoT table and a DevOps table. I'm going to actually create both of them, but make a note that there is some sample data that is loaded in here, and then there would be the associated charges for that amount of data. So clicking the Create Database button here, you should notice the success banner here up at the top and the database appearing down here. So I'm just going to select this database, and you're going to have the two tables that belong to it. I'm going to click on, let's just go on this DevOps one here. Going into the DevOps table here, you're going to notice there's a 1 day of memory retention and 5 years here of magnetic retention. Just to illustrate, going in here, I'm going to just change this to 12 hours of in-memory retention, and we'll just do, maybe a year of retention for the magnetic store. And I'm just going to click Save. You notice there's a warning here because we are reducing the amount of storage, which could cause data loss, but in this case there won't be any in my case, so I'm not too worried about this. So click Save there, and we have our new retention policy set. Next I'm going to go into the query editor over here, and over on the side you can see this is the only database I have in here, but I can expand these here, and you can see the columns that are available within each of these tables for the various records. So if I were to maybe just preview the data, you're going to see that we're going to get this simple SQL here that's just going to query out 100 records out of the table, and you can see, the 100 records down here. It's a pretty simple query. So let's go to something a little bit more advanced here. So if I click on the sample queries over here, you're going to notice that we have a handful of them. There's actually a couple pages here. So maybe I'll pick this one here. This is a more interesting query. This one is about binning the data and then interpolating in gaps in the data. In this particular case, we're going to create the sequence of records, and then we're going to do this interpolate fill function here, run that on here. You'll notice down here there is this cross-join syntax that's going to cross-join these between these series up here. So you can see that, like I mentioned earlier, this is a common table expression here, and we're going to select from the interpolated time series here. So if I were to run this, you'll see we get the output, and you can see these interpolated, values of 10% CPU utilization being filled in into the gaps that we've artificially created when we've created this, this sequence here. So that's really just kind of a simple walkthrough of the Timestream console. Really the only other area really to check out here would be the account metrics, which will give you some sort of idea of your usage of the system. And you'll see like things in here like around the ingestion latency and number of requests and such. So yeah, that's the walkthrough of the Amazon Timestream console. Thank you guys very much, and I hope you found this useful.